Hello, everyone. This event is brought to you by Data Talks Club, which is a community of people who love data. We host two types of events. On Tuesdays, we usually have technical events with presentation, like a workshop. Today is Tuesday, but this event is different, and I'll tell you in a moment. But I can briefly tell you about our plans for the future. So next month, in February, we will have a conference on Fridays. I'll talk about that in a moment as well. But I can already tell you what will happen in March. So in the first week of March, we will have a workshop about building scalable end-to-end data pipeline, a deep learning pipeline in the cloud. And then the week after that, we will talk about active learning and self-supervised learning. Then usually on Fridays, we have sort of a live podcast session where we talk about different topics. And today, even though it's not a Friday, we have a similar sort of event. So this is not a workshop, it's just a conversation. We'll talk about feature stores. And then in March, we will talk about public speaking on the first week of March, and then we will talk about data ops. And speaking of conference, this week we have the first day of the conference on Friday. We'll talk about machine learning use cases. We will have 4 use cases. We will talk about reinforcement learning. We will talk about um, consuming food industry. We will talk about healthcare, and we will talk about using machine learning in manufacturing. Then next week, we'll talk about product and processes. Then we'll talk about career in data. And then finally, on the last week of February, we'll talk about machine learning in production. You can read more about this event on our website, datatalks.club. And we have our friends from O'Reilly and Machine Learning Ops community who support us. Today, during our chat with Willem, we will use Slido for questions. And I'll just share a link with you now. So at every time you have a question, just feel free to use Slido for asking that question. So let me just share it in chat. Okay. And yeah. So last week we talked about MLOps, and one of the topics we covered there was ML platforms, machine learning platforms. And we talked about these platforms, that there are multiple components, and one of the components of a machine learning platform is a feature store. And this week we'll talk about this topic in more details with Willem. Willem is the creator of Feast, which is an open source feature store. And previously, Willem worked at Gojek, where he led the data science platform team. And now he works at Tecton, a company that develops a feature store. Welcome.
Thanks, Alexei. Thanks for having me.
Yeah, it's my pleasure. So before we go into our main topic of feature store, can you tell us a bit more about your background? Well, what is your how was your journey so far?
Sure, I'll give you like the, I guess, 1 minute or 2 minute summary.
Mm-hmm.
So I'm a South African. I kind of grew up there in South Africa, studied mechatronic engineering. After graduating or during my university studies, I built a company, a networking company, and eventually sold that. Went into kind of control systems, automation, kind of the engineering side of like a cross between engineering, traditional engineering, and software. Worked in that industry for about 3 years, and then moved over to Asia, where I continued to work up and down the stack, all the way from like low level electrical and electronic devices up into the cloud. And we built a lot of like vertically integrated solutions for large MNCs, and eventually kind of gravitated towards like large data solutions, kind of analytical warehousing, and did that for about 2 years, and then moved over to Singapore, where I was the first engineering hire for a machine learning. Well, it was at the time it was a data science team that they were staffing. So Gojek kind of I think it was like a unicorn at that stage. It was about $1 billion in valuation, and they knew they had a lot of like interesting products and a lot of interesting data, but they were not doing anything with it. And so they thought, okay, well, everybody's talking about data scientists, data scientists. Let's just hire a bunch of data scientists and solve, some of our kind of like improve our products and bottom line somehow. So they hired a bunch of data scientists, but they couldn't get into production, and so they embedded us as engineers, and they asked me to lead that team to kind of help them productionize their work, because traditional product engineers in the company had a lot of other things going on, and so they couldn't really deal with that. And so that's what I did for about 4 years. And after that, leading that and building an ML platform there and leading a team there, I moved over to Tecton, where I am right now, because a large part of what I was doing was just building feature stores, and that was like my biggest focus at Gojek. And that's what I'm doing right now at Tecton as well.
Hmm. Yeah, that's an interesting journey. So mechanical engineer, did you learn to code at the university?
Oh, so it's mechatronics technically, but mostly focused on the mechanical aspects at university. So I'd say 70% of that was just things that I were not highly interested in, and the
Mhm.
software aspect was always the most interesting part to me, yeah, and the most
Okay.
applicable to what I'm doing today.
Okay. Yeah, that's interesting. So that's like from the very low level to the cloud, like you said. That's amazing. So what are the feature stores? Like why do we need them, and what kind of problems they solve?
Yes, this is actually a big thing that we can get into today, but feature stores basically solve multiple problems. Um, I think it depends on the feature store, but essentially a feature store is an operational data system, but and it is opinionated and targeted towards machine learning. So it solves machine learning specific operational problems. So things like, how do you get features that are offline into an online production environment? How do you ensure consistency between that online and offline environment? Because models require that consistency of data, right? So the features that they're trained on needs to be the same as the features they're served. How do you ship features into production without engineers? How do you allow data scientists to do that? How do you kind of version control and allow data scientists to create new features? So the actual transformation code. Um, how do you allow sharing and reuse? This is one of the ways in which companies kind of get into building or thinking they need a feature store. Typically, is we have all these features that are being duplicated across projects. Why is that a good thing? That's definitely a bad thing. And so there's a smell there, and then they start researching feature stores as a solution.
Hmm.
And then the final one I'd say is, how do you ensure once the system is up and running that only the good data, like valid data, gets served to models? So how do you monitor features, both in the online case as well as just how do you produce statistics for training data sets, and how do you ensure that there's no drift or distribution
Hmm.
shifts, concept drift over time?
Hmm. Okay, so
Yeah.
basically, this is like a data storage that has these nice properties of ensuring consistency, being friendly to data scientists, having version control, and uh, making it easy to use features, right? So when we have, let's say, project A and project B, both might use the same features, right? And
Right. So those are some of the problems that I've seen feature stores solve. Now, there's going to be a big question around what should a feature store solve?
Mhm.
And all feature stores don't solve these. So, for example, Feast doesn't do transformations, and so some feature stores like Tecton's feature store does allow you to do transformations. So the question about which of these problems should be the scope of the feature store. But yeah, essentially that's kind of those are the core problems.
Mhm. And by transformation, you mean we have some data, raw data sitting somewhere in our data lake, or whatever place, and then we somehow need to get this data, apply some function to this data before it ends up in our feature store, right?
Yeah, you'll have multiple sources. Typically, a feature store is so there's one aspect of the feature store that's very important to understand is that it's positioned between the raw data and kind of like your production machine learning environment. So it has access to streams, it has access to your data warehouse, it has access to your data lake. So if you're applying a transformation, it should be able to act on any of those sources and then serve a kind of layer to your production environment that kind of decouples your ML from your data. infra.
Mhm.
Yeah.
So is it difficult for data scientists? Because as a data scientist, I'm used to a certain way of querying data. Like I have SQL, I have, I don't know, usually it's SQL, right? So I use SQL to query data. Uh, does it give this SQL-like interface, SQL-like interface usually for data scientists, or it's something different? How does it look typically?
So there's two aspects there. The one is the production creation aspect, and then one is the retrieval aspect. So most of the types, in most cases, you're pre-computing features, right?
Mhm.
So there's typically in a feature store that allows for transformations, like the Tecton one, it provides a kind of like PySpark or Python-based transformations, or it provides SQL transformations, and then you publish those. It would materialize or pre-compute those features and then persist them in some kind of storage engine like Dynamo, Redis, etc. And then there's a retrieval interface. At the retrieval time, you normally have an API. You don't have SQL. It would kind of defeat the purpose to just provide a SQL interface there, because then you can't have the same guarantees in terms of
Mhm.
performance in production.
Mhm.
And most online models only require kind of key value enrichment of entity data. They don't require, it's like tabular data essentially. They don't require arbitrary queries to be executed. Now, that being said, features, the Tecton feature store and some feature stores do provide on-demand or kind of real-time transformations. So in some cases, some of the data comes from the incoming request. So let's say if like a fraud detection system, a request comes in, you want to act on live data that's attached to that, metadata attached to that order or booking. And so those features are transformed at request time. But for the most part, it's pre-computed. And that's the only place that you'd have kind of arbitrary logic in
Mhm.
most cases. Yeah.
Okay. Yeah. You mentioned this fraud detection. So I imagine a scenario like when a user goes to some, like let's say Amazon or whatever e-commerce store and buys something, right? So we have some information about the user, and then let's say when there is a transaction, we want to predict if this transaction is fraudulent or not fraudulent. Then at the moment, if like when transaction happens, we talk to our model, right? We say, okay, this user with this ID is trying to make a transaction with this and this and this item on this amount of money. So we have the ID of the user, right? And this is what we ask the feature store. Hey, what are the feature for user with this ID? Give it to me, right? This is how it works.
That's correct. Yes. Yeah.
Okay. Okay. And this topic of feature stores is quite hot these days. I'm also a part of a MLOps community, and every day somebody is talking about feature stores there. Well, at least every other day, and it seems very popular, right? So, do you know why it's so popular? Why is there is this hype around feature stores?
I mean, I have my theories, but it's definitely interesting to sit back and just observe, right? Just the amount of hype is just, it's not just feature stores, it's ML ops in general. I think ML has had a lot of hype, and I'm trying just reflecting on that a little bit. But there's a lot of competition in the space, right? I guess in terms of employment and marketability and skills, and it's kind of like the Node.js hype and the IoT hype. I think a large part of it is driven by you can't like a rebranding of your skill set, and so people are incentivized to become kind of niche experts in new fields, and I think that's a small part of it. But feature stores and ML ops provide a lot of value to companies, and a lot of companies are digitizing, and there a lot of organizations will be left behind if they don't implement these systems correctly, and they've tried and failed in a lot of ways over the last couple of years. I'd say from about 2015 2016 onwards. Some companies have succeeded, and they've succeeded because they solved these problems. So like Michelangelo at Uber has, is a success, whether or not Uber is a success. So ML ops is critical if you want to actually use ML for a company at scale. And I'd say we've we've crossed that hump of machine learning platforms becoming standard, right? So everybody's got their whether it's Kubeflow or MLflow or Selden, they've got some kind of stack running models, right? But they realize that data is almost 90% of that equation. The value is coming from producing new features, shipping that into production, exposing that to models and iterating constantly on that. It really depends on your use cases at your organization, but a feature store has massive strategic value in that. I mean, it sits between your data scientists that produce the features and your production environment that makes decisions. So there's an acknowledgement of the value that a system like this could unlock for organizations. And then if you look at the problems that you can potentially solve, there's all this reuse and waste. And so the idea behind solving the problems in that area is kind of profound. Whether or not feature stores solve the problem is a different matter, but there's a definite potential to have massive business impact with feature stores.
So what you're saying is there is hype indeed for MLOps and feature store, but this hype is warranted, right? So this there are some problems, and like data science, machine learning, engineering has been around for, I don't know, 5 to 10 years, right? So the industry is maturing, and there are some problems that are difficult to solve, and these new things like MLOps and feature stores, they help to address these problems, right? And
Yep.
that's why we have this hype, because actually these tools help us to address these problems.
Yeah, or 80% of the hype is like feature store vendors promoting their software, right? So that's
Okay.
just par for the course.
Yeah, so maybe let's take a step back and talk about these problems that data science teams usually have. What are these problems, and are these problems more organizational or technical?
Yeah, I think that's one of the interesting things that I'd love to talk about. It's, if you're at a company and you have problems, normally the problems you like to talk about as an individual contributor are the technical problems, right? Because you think the organizational problems are kind of unique to your organization. But one of the things I learned was that a lot of these organizational problems are kind of, deeply rooted in many orgs, and they're common patterns that occur over and over again. But yeah, we can address those same problems. I mean, we can recap those. So it's like, how do you get features into production is the one we spoke about. Um, we can drill into these. Let me just list them out. There's, how do you ensure online and offline consistency? How do you, if you're shipping data from offline to online, how do you ensure that data scientists can do that without engineers? Like, how do you build that bridge? And then there's, how do you allow them to data scientists to create transformations? How do you allow for sharing and reuse? And how do you monitor, features and data being served to models both offline and online, and ensure quality data there? So did you want to kind of drill into those problems and kind of discuss them individually?
Yeah, but also these are technical problems, right? But
Yeah.
these are not the only problems we have in organization.
Yeah. So I can
Right?
I can I can expand on those. So
Mhm.
kind of shipping features into production, that's, if you want to do that without an engineer, that's kind of organizational problem, right? It's
Mhm.
the original problem is engineers don't want to help me with my,
Mhm.
quote unquote dumb data science project.
Mhm.
They've got their product that they're developing, they have OKRs, and they've other objectives. And so data scientists are often second class citizens. I've seen in a lot of, I mean, they're some of the best people, but organizationally, sometimes they're treated like second class citizens, and their use cases and goals are not always placed at the front, right?
But expected to be you know, do the magic and do all this engineering work and make things happen.
I think a part of the problem is also data scientists, there's not a deep understanding of, the value that a data scientist can bring, or ML, because, there was so much hype, and then a lot of failures occurred. And with data science use cases, failures are normal. Sometimes they don't work out, and that should be expected. And so I think organizations are kind of, placing data scientists sometimes into a corner and saying, you know,
Mhm.
you're not the primary focus, and you don't drive the bottom line directly yet. But that's changing over time. Okay, so shipping features into production came from an organizational frustration, or serving features online is something that data scientists need, right? If you want to iterate on a feature, you need to get into production. You need to see the results of the model improving, running your A/B test. And so that's an organizational friction if the engineers can't help you with that. Um, Sharing and reuse, that's an organizational problem as well, right? So you've got silo teams, they don't have communication channels between them, they don't have infrastructure or a way to broadcast how their features are being created, what the intent, what are the semantics, what are the dependencies of the transformation and the data that's being created in production systems. So there's a kind of social aspect to sharing and reuse, and there's a trust aspect. And I'd say that that's largely kind of organizational problem.
Mhm. Okay, makes
Yeah.
sense. So we have multiple teams. Every team is doing is solving their own problems, um, and they are building their own services, and they're building these machine learning solutions. But at the end, it turns out that there is certain overlap between the work that two teams are doing, because they might be solving different problems, but some of the features, like let's say user-based features or some other sort of features, they're common, right? And but they have to implement them from scratch, and this is an organizational problem.
Yeah, I'd say it's a lot of organizations, I'd say, are taking a flat approach to these teams, and they kind of embed them in product teams and
Hmm.
verticals. And often, like say, like a fraud team and like a team doing analytics on user data have they have the same entity data. Sorry, they like they say doing user types of modeling, right, or order modeling. The features are common and reusable across those teams. Um, but let's say the fraud data science team has an air of secrecy because they feel like what they're working on shouldn't be exposed to other teams. So those are kind of organizational inefficiencies, right? If you look at it from like a CDO or a CIO's perspective, it doesn't make sense for some of the data and work to be duplicated. So that is definitely an organizational inefficiency that you could solve through technology or could solve through some other means. Yeah.
Yeah, and then the solution would be to, in addition to these multiple teams that we have some sort of central team, or maybe central piece of technology. Like, I don't know if there should be a team or not, but like a place like ML platform that is common for all the teams, and this feature store is a part of this ML platform, right?
Yeah, that's right. So at Gojek, I mean, you can architect this different ways, but there's an end-to-end ML lifecycle, and at each stage of that lifecycle, you pretty much have a tool or multiple tools that allow you to get further down that road. So it's
Hmm.
something like data transformations at the start, kind of data storage, model training, model serving, model deployment, and then kind of the serving aspects and experimentation at the tail end.
Hmm.
Yeah, but the feature source sits in kind of the data transformation and the kind of data serving aspects. Yeah.
Hmm. And then the idea is that we have this platform where we have all these features. By features, I mean these capabilities of a platform. And so then basically data scientists do not need to rely on data engineers or other engineers who are busy doing their own OKRs, like you said. So they can basically go ahead and uh, do these things, especially if these
Yeah.
features are already pre-computed. So there is this, we already have this transformation job running all the time and putting the data into feature stores. So they can just go there, see what features are there, uh, and pull these features and train their model, right?
Yeah, so you can just think of like a utopian end state as you don't write any boilerplate, you only write your transformations. Easy way to iterate. You deploy that, then it gets materialized, backfilled, stored into an offline store, an online store. Then there's some kind of API that your model can access in production or even development that allows you to kind of enrich incoming entities like user IDs or anything like that with features. So you can do all of that without an engineer and then kind of deploy your, let's say it's like a Python or kind of model wrapper into production. And it's just a platform that carries you all the way through from kind of like raw data all the way to prod. That's the kind of like dream state. And then ideally you'd also have like a validation layer that's giving you monitoring metrics and ensuring that only good quality data gets
Mhm.
to your model.
Um,
Now it's
yeah, I'm
sorry, go
just
ahead.
curious, like this dream state, like it looks really awesome. But are there companies that actually who are already there, or
Well, you can't ask me that if my employer already
okay,
provides a product like that. I mean, if you look at companies like Uber,
that you
and if
have
you look at the
Michelangelo,
product
right?
that they've built at Tecton,
Uh-huh.
uh, I mean, from a feature store perspective, you already have that.
Okay, so
So if you,
basically, like, I'm sorry for interrupting. So,
yeah, so if you have the ML platform and the rest of the
mhm,
components, and you plug that into Tecton, then you will have that complete flow. If you have something like Feast deployed with an ML platform, we don't do the transformations. And so you'd need to have some system upstream that's doing transformations. So the system that we typically recommend is DBT or, Airflow and ETL if you want to use Spark and things like that. But that's not something that Feast addresses today. Yeah.
And Kubeflow pipelines, I guess, also fall into this category, right?
I would not use Kubeflow pipelines for transformations, but I'd use it for training models. That's a good tool for model training. Yeah.
Okay. So this is something that lives separately from that, right?
Yeah, I consider those kind of like separate, tools in terms of which stage of the life cycle they address. Yeah.
So what is Feast? It's an open source library, right? That you created, but what problem does it solve?
Okay, so Feast is a feature store. It's one that we built at Gojek and productionized and operated for a few years as part of the ML platform stack. It solves many of these problems, or aspirationally, we tried to, solve a lot of these problems. We didn't solve all of them. So we set out to solve like how do you serve features online, offline, online consistency, provide a way to kind of like, work, publish data into production without engineers. And the sharing and reuse and monitoring aspects also came with that. The sharing and reuse is something we didn't solve. So we didn't really double down on kind of a UI and discovery and all those things. And we didn't do that because, halfway through we realized many of these teams are happy just duplicating code. They're happy just duplicating pipelines and organizational, or, eat up the cost for a pipeline running again, and nobody's going to question that. And there's a good reason for that. It's, you protect your production environment by duplicating pipelines and not giving control to another team to shut down a pipeline. So what Feast mostly solves today is how do you kind of decouple your production machine learning environment from your kind of data infrastructure. So we provide a way for you to ingest post-computed features from streams as well as from batch sources into the feature store. And then we provide an interface for you to build training data sets in a point-in-time correct way. And then through a unified interface, meaning your model uses the same API to access features for training and online. You can also then retrieve online features at low latency. So we use Redis for online serving there. So Feast is that software that we built at Gojek, and we open sourced it. We co-developed it with Google Cloud actually, and then we open sourced that. And subsequently, I've joined Tekton, where I continue to develop Feast, and it's kind of one of our offerings and something that we're very focused on. Yeah.
And Tekton, as I understood, so Feast is an open source project that you can just go ahead and install it on Google Cloud and I don't know, AWS as well.
Yeah, so we've been spending a lot of time kind of generalizing it over the last couple of months. So you can deploy it on Amazon, you can deploy it on Azure. We actually have folks deploying it on Azure right now. We just launched a Terraform deployment for Azure if you want to try it out. And of course, GCP. Yeah.
And then Tekton would be like, okay, if you don't want to do all that, like setting it up on your cloud, you just go and have like it as a end-to-end package, right? So you just use it as a service.
So I think Tekton is a little bit more full-featured. So Tekton is a complete platform. It's like if you're an enterprise user or somebody that wants the complete lifecycle, so transformations, user interface, on demand. So it's like streaming transformations, on demand transformations, it's batch transformations, it's a UI, it's monitoring. It's a complete feature store. So you also have kind of like security and auditability and compliance related functionality there. So it's really targeted at companies that just want to solve this problem today, and they understand the value of feature stores. And Feast is mostly targeted at teams that are happy to build and kind of slot in a smaller tool into a larger stack. Yeah,
like this Unix concept when you have many small tools that do.
Yeah, but at the end of the day, feature stores are still a little bit overloaded. They're trying to solve a lot of problems, and so they're not really little tools.
Yeah, we have a question. Could we take a step back and say what are the basic components of the features of each feature store are? So you mentioned that there is like the actual data storage for offline and online. calculations, right? So I don't know what for online you mentioned Redis or Dynamo. Then for what do we use for offline storage usually?
There's a great blog post that I wrote for with Mike Del Balso for Tecton that I want to plug, which is what is a feature store, and in
Mm-hmm.
that we describe the components. And so we'd say there's a transformation or computation engine.
Mm-hmm.
So you'd have your upstream data sources like stream or batch. Then there's the transformation system like Spark or SQL in a warehouse or something
Mm-hmm.
that transforms. Then there's storage layer. So normally there's like an offline and online storage. So in the case of Tecton, the offline storage is an object store like Delta, but you can also use a warehouse like like BigQuery or Snowflake as the offline store.
Mm-hmm.
And there's also the online storage, and in Tecton's case, that's Dynamo, and Feast case, that's Redis. So normally it's a key value, low latency store for online, and it's kind of like a large big data lake like or warehouse like Hive, BigQuery, Redshift, Snowflake for offline. So those are the two components. There's compute, there's storage, and then there's a serving layer, and that's
Mm-hmm.
normally just an API that allows you to read from the either the online store or offline store, or sometimes we just use an SDK to read from the offline store. So it's a query generator.
Mm-hmm.
So serving is the third component there. Um, a critical component in a feature store is the registry, and both Feast and Tecton has this, and I think most feature stores. And so you define like schemas that describe where your data is upstream, and schemas and definitions that describe the transformations that you want to apply, and you register that into the registry, and then this feature store can you know execute or implement those schemas as infrastructure. So either it creates the tables in the warehouses, or it runs the computational jobs based on the definitions in the registry. And the final component would be just the monitoring layer. So there's normally a monitoring component in a feature store that ensures that you know it tracks data being ingested from streams, data being computed there. It tracks data being read from batch sources, and like row counts and distributions and all kinds of things there, and then data being read out of the feature store. So what we often find is that teams, especially in the fraud side, if they're reading data from the online store, will log those features back into like a warehouse. And you can use that for training data, as you can also use that to validate the data being served to models and ensure that there isn't drift. So those are the five. It's the transformation engine, there's the storage engine, there's serving layer, registry, and then there's the operational monitoring layer.
Mm-hmm.
Yeah.
And registry also usually like there is some certain user interface component where people can just go and take a look at the features.
Yeah, so the more advanced feature stores have kind of like a user, just like a feature discovery and an entity discovery interface they built in the registry. Yeah.
Okay. And yeah, let's say we want to start using the feature store at our organization, right? And probably it will also come with a machine learning platform. Um, so how do we go about doing this?
Okay, so first it depends on what your use case is. So I'll talk about the use cases that typically aren't a good idea to use a feature store
Mm-hmm.
for.
Okay.
The ones we've seen, like selling a feature store inside of Gojek, where we had 16, 17 different products. I know which use cases are not really applicable. So if you have batch use cases only, it's probably not necessary for you to have a feature store, even though it does add a lot of value if you use something like Tecton to do transformations. But you can maybe just get away with DBT. If you
Mm-hmm.
have computer vision or NLP or super unstructured data, then probably not a good idea.
Mm-hmm.
But if you do have online serving needs, if you're using kind of tabular data, or so let's say fraud detection, or anything that has something to do with kind of like product recommendations or user risk scores or fraud detection. So at Gojek, we had a lot of like ranking systems and price optimization systems. Anything that you kind of want to have a entity coming in or multiple entities, and you want to enrich them with features,
Mm-hmm.
and you can use those features in, let's say, just the traditional models like XGBoost, scikit-learn, TensorFlow, PyTorch. That's a great use case for feature stores. So Feast primarily solves kind of, for Feast, I'd say the big value add is going to be that online serving layer
Mm-hmm.
and the unified access. So if you want to use, let's say, Feast in your organization, you'd implement that after your transformation pipelines. So you already, we assume that you have some system to do transformations. Let's say it's BigQuery to BigQuery, or it's batch to batch, and then maybe you have some streaming transformations. You not So what some teams do traditionally is they transform data and then they write it directly into the production environment. we don't recommend that architecture. What we recommend is if you transform a stream, you push it back to a stream. And if you transform a batch data source, you push it back to your lake or warehouse. And then the feature store is kind of like the layer that slot that bolts on top of that. And then you can with the feature store pick which columns and tables you want to productionize and make available in your environment for serving in your production environment. So that's how you'd use Feast. You'd apply it on your existing batch and stream sources. For
Mhm.
Tecton, you'd potentially not even need to have your transformations. Like you could read from your existing transformed data, both streams and batches, but you could also just read raw event logs with
Mhm.
Tecton and then transform it using Tecton. Yeah, but
Yes.
but typically they're deployed between your data infrastructure and
Mhm.
your production
Mhm.
serving environments. Yeah.
So just to summarize and to make sure I understood correctly. So let's say we we want to start using feature stores, and for Feast we probably already have some data infrastructure. Let's say we use dbt or airflow or something like that, and then we can just add this on top of existing pipelines, on existing data transformation, and just register, like our can just point out, okay, in this table we have these features. You can just take them and put them to the offline to online storage, right? Okay, and
Yeah. So
with
basically, you have some kind of existing pipelines that are producing schemas
Mhm,
schemas for specific tables. Let's say it's Snowflake, and you then register those tables
mhm.
using feature definitions in the feature store, and then the feature store would be aware of those tables, and then it would start productionizing them. Yeah,
Okay, and what Feast would do in this case, it would take these features from our offline store of our data lake, Snowflake or whatever, um, and put them to online storage, right? To
that's right. Yeah.
Redis. Okay, and then in case of Tecton, there are a lot more options. So basically, you can also start doing transformations there, plug it into some existing set like logs and events, and it will just uh, take this information, take these events, and start
Yeah, I
producing
think the
features.
key difference there is that with Feast, you want to point to tables that are already
Hmm.
featureized or
Okay.
transformed because you don't want to serve raw event data. With
Hmm.
Tecton, you point it towards your raw event data and your data lake, and you can then give it a transformation, and it'll compute that for you. Yeah.
And you mentioned when I asked this question, you mentioned that there are some cases when a feature store is not a good solution. So you just wanted to talk a bit about that as well. So you mentioned that we don't need a feature store when we have batch processing, right? So when we already have.
Well, it's not that you don't need a feature store. It's a feature store like Feast is not really that useful
Okay.
if you are using, if you just need batch scoring.
Hmm.
So let's say you're just running like batch campaigns, like
Hmm.
some kind of you know marketing campaign or something that you're using machine learning for. You typically don't need that. You can just write everything in SQL. Like you can
Hmm.
just use BigQuery and BigQuery ML or something like that. There's no online serving component. You can
Hmm.
write your own validation using Great Expectations or DBT or something. Um, in the case of Tecton, it's actually quite valuable to use Tecton for
Hmm.
that still because it gives you the transformation system, but takes away some of the kind of key aspects of the feature store in that it bridges the kind of offline and online worlds.
Okay. Yeah. So basically, in this way, if we let's say use Tecton for that for our batch jobs, the moment we decide to go online and start serving these models online, we already have everything. We can
Yeah,
just
that's right. Yeah.
click a button
Yeah.
and then we deploy a web service.
Yep.
Okay. And then you also mentioned then we have less structured data. So like when we have tabular data uh, and we want to build an online model on top of that, then a feature store is a great solution for that. But when we have less structured data, and it could be like images, texts, and things like that, then this is not the best solution, right?
Yeah, it's kind of like what is the value that you're going to have at that point?
Mm-hmm.
So I think it still provides a lot of value in allowing you to serve data, right? So you can kind of ship, uh, you know,
Okay.
you can ship blobs of binary into production. You
Mm-hmm.
can make it available. That's something, right? But then imagine you have like a 2D image and you're just storing that as like a like a two-dimensional cell. It's like,
Mm-hmm.
you know, some ID that you look up and it's just like a 2D array, right?
Mm-hmm.
Of bits or something. But I struggle to see where the value is, and especially in the kind of like a reuse case and the semantic case, because normally with features you want to have like each feature column has some kind of identity, right? You have an understanding of the intent of the creation of that feature.
Mm-hmm.
But if it's just a binary blob, then it's pointless almost.
Mm-hmm.
You can serve that data online, but no other team is going to discover that and unpack that and understand
Mm-hmm.
what you're doing. It's going to be purely for your use case.
Mm-hmm.
So you're kind of like using the feature store as a means to an end, but it's not really building efficiency in your team if you're using it for those use cases.
Perhaps a good use case would be, correct me if I'm wrong, that let's say we have a model, image classification model. We apply this model to images and then save the results. And let's say we have a model that says what is the probability that this image is an image of a car, and we just save it as a feature. Okay, this is the probability that this image is a car, and then basically in real time we would ask the feature store, hey, give me the probability that this image with this ID is a car, right? And it would give back the predictions. This is a good use case, isn't it?
Um, I think if you're using those aspects of the image as outputs, and those
Mm-hmm.
outputs go into the feature store, and then subsequent downstream systems can use, those probabilities as features themselves,
Yes, exactly.
that's a great use case.
Uh-huh.
So you can
Yes.
have a column that is like, is car, and that's maybe just a binary, and there's maybe
Mm-hmm.
like probability car, it's like 0.7 or
Mm-hmm.
something. That's a great input to a model, the subsequent model. But if you're storing just, I mean, if the input to the model itself is the image, and the image is coming from the feature store, I don't think that that is a great use case of the
Mm-hmm.
feature store, even though that is a good, because normally that input is not going to come from the feature store. So normally the incoming request is going to have like, a request ID and model URL on S3, and then you can download the image from, sorry, the image URL from S3. You're going to download that image, and then you're going to feed it to the model, and
Mm-hmm.
that's going to take 10 seconds, and then you're going to get some
Mm-hmm.
output. But you're not really going to read that image from the feature store in most cases
Mm-hmm.
because, um, it's just not a good use of the infrastructure because you don't have the latency aspect. It doesn't have to take milliseconds. Um, but the output of that is something you do want to store in a feature store, and that's actually something we saw a lot in Gojek. So you have all these ML use cases, models in production, and the output of those models go back into a stream, and then from the stream we read it back into the feature store, and you kind of build these cyclic, reinforcements of expanding your data foundation, and you can reuse those output of models as features because essentially the model is just the transformation itself. So
Mm-hmm. Yeah,
yeah.
exactly. Okay. Let's say I want to learn more about feature stores as an individual contributor working at the company. And yeah, this is an exciting topic. Everyone is talking about this, and I just want to learn more about this. How would I, uh, how would I do this? Like, is there a good suggestion for me to start learning this thing?
That's a good question. I mean, I think you can just literally go to MLOps community.
Mm-hmm.
There's a lot of resources there that people have posted, especially in the data ops channel, the open source channel, just the general channel. Read some of the articles that are being posted. We're also happy with our competitors' articles being read, but have a look at the Tecton blog. There's some good articles that we put out there that explains our thinking about it. We're spending a lot of time right now thinking about the category itself and what a feature store should do. Really, a lot of time, and some like great minds from Google and Uber, thinking about the space. Um, but the articles that we've written on the Tecton blog are great, and I think you should also maybe have a look at just MLOps community. There's a lot of
Mm-hmm.
resources there.
Mm-hmm. But these are more like maybe perhaps theoretical, but like, is there something hands-on we can do? Like, I don't know, maybe just set up Feast on our laptop
Oh,
and
right.
like
I mean, if
play
you
with
just
this.
want to try it out, if you want to
Yeah.
physically, like literally just install it, you can just go to feast.dev and try it out. You can run
Mm-hmm.
a Docker compose of Feast and run through the notebook. There's an example notebook.
Okay. Yeah, and that should give sufficient understanding on of what this is, and let's say if if I see at my company there is a similar use case, I can just go ahead and propose it to.
Yeah, I think one of the things that we've not really succeeded at is articulating all of the use cases where it would be valuable. That's
Mhm.
something at Feast, we've kind of failed at yet for the time being. Something that we want to focus on in the next couple of months is producing more content that it explains and grounds the feature store within a organizational context. You can have a look at the Feast docs. We explain exactly the why, when to use a feature store and when not to. If you
Mhm.
look at our documentation, you don't even have to install it. Just go and read those docs. Um, but I think there is sufficient content on MLOps community that explains how people are using feature stores, and even some companies and teams like Monzo and Neil Athia that
Mhm.
explain how he built the feature store to solve a specific problem, and it looks completely different and it's a lot more lightweight than we did it, um, but it's still relevant to
Mhm.
solving some of the same problems. Yeah.
And yeah, he actually mentioned that they use feature stores for storing text data, which is
Yeah.
interesting.
Yeah.
So we have a question. What workflow do you recommend for engineering new features, testing offline performance, and making sure that offline and online data matches?
Well, I mean, there's challenges there. If you're using a feature store, it looks different from not using a feature store. Um, we typically treat transformations separately. So we have streaming transformations that we treat differently from batch transformations. So in the batch case, you can have DBT or some kind of transformation system. And then you have you have, validations built into transformations, and you have like stream transformations with, perhaps you can have like a logger that's syncing that into a batch environment. And then you can have some kind of system that gets triggered to validate data, and you can use great expectations or TFDV to do that. So there's kind of four areas where we hook into validation systems. So that's streaming, ingestion, and transformation. There's the batch validate, the batch transformation, and pre-ingestion into the offline store validation. And then there's training data set, like right before you train, you can validate, and right before you serve data to the model itself, you can also validate. So those are the four main points. Um, and and with a feature store, you get those hooks and like trigger points to validations. If you don't have a feature store, you can also just run your code there. You can have a repository with great expectations and just apply those expectations on your data. I'd say for most teams, covering the batch features is probably the biggest concern, especially if they're productionizing analytical data that other teams are creating. um, but yeah, you have to take a defensive approach, and the unfortunate reality is if you don't have a feature store, you probably have to write a lot of boilerplate code in order to prevent bad data from reaching your models. And so your model serving layer is going to have a lot of if x greater than something, then produce some kind of alert. You're going to have a lot of excuse me, hard coded logic there. Yeah.
And great expectations, you mentioned this a couple of times. This is a tool that allows you to do these checks, or what is that?
Yeah, great expectations allows you to you create data, and then you can kind of use it to profile your data, so you get an understanding and properties about columns and distributions. Then you can store and encode these expectations about your data, and then subsequently, when you create new data sets on the same features, for example, like different days, you can run those expectations to ensure that your data hasn't changed,
Mm-hmm.
and you can kind of layer on more expectations about your data. So you can say like the range of the data is within these bounds, or the distributions within a certain shape, or these are the categorical elements of this, and these are like nominal features.
Mm-hmm.
um, so yeah, great expectations is great, mostly focused on batch today, but we're
Mm-hmm.
hoping that tools like that will also become available for the streaming use cases, and
Mm-hmm.
that's
Yeah,
something that we're trying to solve with feature stores as well.
it sounds incredibly useful. We have another question about streams. Do you have any opinion on Apache Flink versus Apache Spark for calculating real-time features?
Well, we started with Apache Beam, and Beam and Flink are very similar. I'm a big fan of Apache Flink. Um, Most of the engineers that I respect also have very high regard for the project because of its API. It's a really great API. Um, we are using Spark with Feast today because of its ecosystem and connector support. I'd say in terms of the raw technology itself, Flink is superior, but um, the ability for Spark to execute in multiple environments, so you've got like traditional Hadoop refugees, and you've got clouds like GCP and Azure and Amazon that allow you to run Spark jobs relatively easily. It's not there yet for Flink, and a lot of companies, they'll happily run Spark, but if you say Flink, then they'll say, okay, well, now we need to implement a new runner. Although there are a lot of companies that are today running Flink, and some of the cloud providers do now support running Flink. Like I think it's possible on Amazon.
Mm-hmm.
So I'd say it's probably get there in the next year or two. But there's not much difference between them right now in the way at least we're using it. Yeah.
Yeah, I think there is a connector for Kinesis in AWS for Flink, if I'm not
Yeah.
mistaken. I think I remember seeing something like that.
Yeah.
Who are Hadoop refugees?
All those, folks that are running either on premise or they've got large Hadoop stacks, HDFS and things like that, and Hive that
Okay.
inevitably will need to get onto BigQuery and Snowflake and modernize. But for some companies, that's going to be a 10-year effort.
Okay. Yeah, that's a funny name. What APIs are provided for feature transformations? Is it similar to building Spark Beam transformations?
Yeah, so in the Tecton case, it's like PySpark,
Mm-hmm.
Spark SQL. If you're using an existing warehouse, it'll be like SnowSQL, BigQuery SQL. And for online transformations, meaning just in time or like request time transformations, it's it's just Python. So you can write pandas transformations or any kind of Python transformations. I'm sure that some teams are running Scala transformations in
Mm-hmm.
production as well. Yeah, but that's not supported today with Tecton. Yeah.
And for Feast, it doesn't matter, right? Because Feast doesn't care about what
Yeah, so it's
technology
something that we're
you use.
considering adding, but it's not something that's going to land soon. On-demand transformations is actually something that a lot of teams have asked for because there's a lot of request time transformations, and if you think about it, it's a big problem to unify on-demand and the online and offline aspects there. Like if you're running kind of Java transformations in production, you kind of have to go back to the data science notebook to ensure that they have the same transformations being applied to their training data sets. So it's something that we want to address.
Yeah. Okay, thanks. Then we have a question more about like organizational. At what size of a group does it make sense to build a feature store?
That's a good question. Traditionally, I would have said, you have multiple use cases. So one team, like let's say 2 or 3 data scientists with multiple projects, or you have multiple teams that have like just one project and they kind of want there's some sharing and collaboration that they need between them. I'd say that's the current state of the industry. We're looking at whether with Feast we can address like a single data scientist, add value to either a single data scientist or a single team on a single use case. That's where we want to get to. We see that as like the kind of ideal target state, but not sure if feature stores will ever get to that point. The current status quo is still platform team addressing multiple kind of solution oriented teams. Yeah.
So let's
So
say if we're a small startup and we're just starting with data science, and let's say we hired our first data engineer and I don't know, data scientist, should we already start like using feature store, or maybe we
yeah,
should wait?
I don't think it makes sense to start like if you have a feature store that allows you to do transformations, yes, that makes sense. But you don't have the organizational friction in that case, right? Normally, folks have multiple hats that they wear. The data engineer and data scientist sit next to each other. Maybe the data scientist is the CEO. Who knows? Uh, so, if you want to ship features into production, you're just shipping like 10 features and 20 features, and maybe you have one model. It's not a big deal. I think it's when you want to iterate on those models when it really becomes a core of your business, when you have multiple use cases, and when the teams start to kind of become independent and they're not working side by side every day. That's when the feature store starts to pay real dividends. Yeah.
And
So I
would it?
wouldn't say it's absolutely necessary for a team
Mhm,
of 2 or 3, data scientists and engineers to
mhm.
start with one.
So it will not be too difficult to start using it later. So like it doesn't make sense to do it upfront in case that later it becomes too difficult to move our pipelines.
The biggest friction we see is normally the transformations. Let's say you're using Airflow and Spark, or you're using
Mhm,
dbt. If you already have all your transformations in one place and you add a feature store that allows you to do transformations, then you have it in 2 places. And so with Feast, it doesn't do transformations, so it's an easy one to slot in. With Tecton, it's also easy to slot in, but you need to make a decision where you want your transformations to live, and whether you're
mhm,
okay with living in Tecton or Tecton just layering on top of so there's that question. So it's not harder. It's just you need to kind of commit to a single approach eventually, and inevitably you'll have people on both sides. The greenfield projects will want to use Tecton, and the kind of brownfield projects that already have everything implemented upstream, they'll want to say, okay, I don't want to migrate my transformations, and so there
mhm.
might be some friction there.
Okay. Brownfield project, interesting. It's first time I hear this. I've heard greenfield, but not brownfield.
I hope that's a thing. But you understood
That's
what I
the
meant, right?
opposite, the opposite of greenfield, right? So an
It's
existing.
like an existing project,
Yeah.
yeah.
Okay. So what is your take on DBT and Feature Store? From what I understood, you previously said you like DBT and it's a great tool. Do they play together well with feature stores?
Yeah, I mean, it's not really DBT specific, but data warehouses are taking over. And I don't think that, the stack of the feature is going to be data lakes and object stores. It'll be some kind of unified SQL interface or some kind of platform that scales out. Like, you can already see how BigQuery and Snowflake are kind of dominating the space. So
Mhm,
feature stores slot well onto those systems. And if you, it depends on the feature store, but if you already have DBT in place for your batch transformations, for I'd say most companies, that's already solving 80-90% of your transformation needs. So that's why there's a good synergy between those two. And also, um, it, a lot of companies and a lot of organizations that are large have a lot of analysts, and those
mhm,
analysts can produce a lot of features. And something we're seeing a lot right now is chief data officers, chief information officers saying, I want my analysts not to just contribute to dashboards and reports, but why can't they contribute features that actually drive the bottom line?
mhm,
And the gateway to that is SQL through a warehouse. And so
mhm.
DBT enables that, and some feature stores also enable that.
Okay, and how do you usually go about setting up features back in time, let's say in BigQuery or in Google Cloud Platform?
Sorry, I didn't hear that. Can you
Yeah,
just
so the
repeat that, please?
question is just reading, how do you usually go about setting up features back in time? So when you want to calculate a new feature, I assume you need to go back in time to actually recompute it for historical data. How do
Oh, good
you
question.
do that?
Yes, in the case of Feast, it's different from Tecton. So in the case of Feast, the upstream system is doing the backfill, right? So if you publish a new feature, that's a new iteration of an ETL or an ELT pipeline that produces a new output that has to be, you run it with Airflow, backfill it, and then you call the feature store and it'll re-ingest those features into the online environment. In the case of Tecton, you change the transformation, but the source of the data stays the same. But by changing the transformation, you produce a new feature, and so it'll know that it doesn't have that in the new features in production or in the offline store, and so it'll automatically start backfilling. So you set a start date and say, let's say it's the start of 2021, and it'll know, okay, I need a daily feature for this feature table, and it'll start materializing the data for you. So it's
Okay.
mostly automated. In the case of features Feast, you just need to send it an API call to re-ingest the data.
Mhm. Do you have time for a couple of more questions?
Yeah, go for it. Yeah, I have time.
So who, in your opinion, should maintain features in Feature Store? Should it be as close to the source or the one who benefit the most from these features or some central team?
Oh, that's a good question as well. So we've seen probably the most sane approach seems to be you don't gatekeep at all, because if you're as a central team kind of gatekeeping and having to police features, you slow down the work a lot. what normally happens with feature stores is that you have specific ML use cases. So there's a proof of concept for the feature store, and there's another use case and another use case. And over time, you start to see similarities and patterns. And when the reuse starts to happen, you can track the reuse of features. A central team can step in and say, well, either this feature is being reused and you can kind of just take ownership of it because it's so important for most of these use cases that are actually running in production, or you can see these features are duplicated but very similar and there's not reuse happening, but there should be. And you can say, I'm going to kind of take this out and own it and, build a golden data set or a golden feature set and control that as a central platform team and then force those teams to kind of adopt your features or at least coordinate the kind of deduplication of those features. But normally the process is organic. It's not something that you start off with a coordinated set of feature because the features won't be perfect from day one. And it's best to let the data scientists iterate on them. And when it stabilizes, then you can kind of pull them out. The worst case is for you to, as an engineer, to kind of step in and dictate how the feature should be created.
So basically, it just happens organically. First, data scientists look after features, but when the central team sees that there are some, duplication or things like that, and then they can start taking care and start maintaining these features themselves.
Yeah, it's normally not. It's normally driven by importance of the feature. Like you can see the feature importance based on the model itself, and then you know how much of an influence that feature has on decision making. And so sometimes you want to take control of that because you don't want like a junior data scientist to change a SQL query and that has a production impact that has a bottom line impact on the business.
Okay. Yep, thanks. What is the difference to a data platform with ETL preparation and a good store catalog? So how is it different from these catalogs that we have in traditional BI world and these feature stores?
I think there's so let's track back to the first thing that we said when we talked about a feature store. It's an opinionated data system for operational data for machine learning. So those operational and machine learning are the two kind of keywords there. Traditional data platforms are not focused on serving low latency data. And if they have a means of serving data at low latency, so if you look at like Databricks or if you look at Snowflake, there's no like online low latency aspect there. And if they add that aspect, then is that built as a traditional kind of, low latency data as a service, which isn't what the feature store tries to solve. The feature store tries to unify that interface, the online serving and the offline, specifically for machine learning models. And that requires those two to be identical. So if you query it with a specific list of features and entities, it should produce a data set that is identical in the offline case and the online case. So there's a specific constraint that's applied to to those two kind of serving environments. In theory, a data platform could provide this, and that's why a feature store is a part of your data platform stack, essentially, right? It's also part of your ML platform stack, but it bridges those two worlds. So it's an opinionated component within a data platform, I'd say. Yeah.
Yeah, makes sense. We still have 7 more questions. I don't think we should keep you for that long. What I propose is I'll share these questions in Slack. And if you have some time, maybe you can come at some point and answer these questions. Or maybe we in the community will take some of these questions and answer them as well. So thanks a lot for coming. It was a pleasure talking to you. I learned a lot today about feature stores, and I already have some ideas how I can try to use them and when I should not try to use feature stores. That was an important thing as well. So thanks a lot, and thanks everyone else for coming today and listening and asking questions. Thanks,
Lexi.
Yeah, have a nice day.
Bye.